b by j omega into e power minus b plus j omega t plus 1 minus b by j omega into e power minus b minus j omega into t bracket close plus q naught. Is that clear, sir? Is that clear, sir? We don't need this expression here afterwards, and therefore let me rub this off so that we can proceed further. Okay? E power minus bt is there. I will take the e power minus bt outside. This becomes 1 plus b by j omega into e power j omega t plus 1 minus b by j omega into e power minus j omega t plus q naught. Am I right, sir? Rearranging, just rearranging. J omega t. Similarly, plus e power minus j omega t. This 2 is there in the denominator. Let me take it inside. Therefore, if I take it inside, I will write it as divided by 2. No harm, right? Then plus I will put this in bracket. B by omega. J is there. Bracket open. E power j omega t minus e power minus j omega t upon 2j plus 2. You know how I'm writing like this, sir? If you recall your trigonometry knowledge, you know that e power j omega t plus e power minus j omega t upon 2 is cos omega t. Therefore, minus q naught e power minus bt into cos omega t plus b by omega sin omega t plus q naught. Am I right, sir? Now what we do is minus q naught e power minus bt. I will multiply by a k, divide by a k, value will not change. I am dividing by k, therefore I have to multiply by a k. K cos omega t okay. Let me take omega outside first. If I take omega outside, this will become omega cos omega t plus b sin omega t plus q naught. Correct, sir? Now I will write this as minus q naught e power minus bt upon omega. I am multiplying by k, dividing by k, value will not change. Plus b by k sin omega t plus q naught. minus bt into k by omega into cos omega t sin theta plus sin omega t cos theta. Right, sir? This will now reduce to q is equal to minus q naught e power minus bt by omega into k into sin omega t plus theta. This is the final expression I got. Okay? One plus q naught I have left. Am I right? Plus q naught I have left. I have left a plus q naught, which means I can modify it further. I have left a minus plus q naught, which means that expression will take a form q is equal to q naught into, okay, q is equal to q naught 1 minus k e power minus bt by omega into sin omega t plus theta. I think this must be the final expression. Exactly it is. Q naught into 1 minus k e power minus bt upon omega into sin omega t. What does this mean? It involves a sign. If it involves a sign, it means the charge is oscillatory. I will draw a graph and try to explain it to you what I exactly mean by it. Let us say this is maximum value q naught, charge q, this is time. Okay? First I said, in the first case, the charge is critically damped. Let me draw that first. The critically damped charge. Okay? I will mark it as A. Then I said, the charge is dead beat. It rises slowly. It is neither oscillatory. It rises slowly and reaches a maximum. It will be something. I will redraw that. It will be something like this. Okay. The third case, this I will call it as B. This is the case where B squared is greater than K squared. This is the case when B squared is equal to K squared. Okay. The third case, how the charge will be? I will draw it in a different color. Okay. This charge raises above and below the maximum value until it reaches the maximum value Q naught. And this is the case of B squared less than K squared. The discharge is oscillatory. The discharge of the capacitor is oscillatory. What decides whether the charge is oscillatory or not is definitely the values of B squared and K squared. If B squared is equal to K squared, I said it is critically damped. When B squared is greater than K squared, the charge is dead beat, which means the charge raises steadily until it reaches its maximum value. When B squared is less than K squared, the charge is oscillatory. It oscillates above and below the maximum value Q naught until it settles to the final value Q naught. One more important thing I would like to highlight here is the question paper may setup may ask you, giving the values of L, R and C, check whether the circuit is oscillatory. If oscillatory, find out its frequency. What do you need to do? Let me tell you what you have to do. If you are able to see the board here, this part, I will say for the circuit to be oscillatory, B squared should be less than K squared, which means what is the value of R? B squared R squared upon 4L squared should be less than 1 by LC. Sir, if the question gives you the value of R, L and C, you find out this value. You find out this value. If R squared upon 4L squared is less than 1 upon LC, you can say the circuit is oscillatory. If oscillatory, you have to find out the frequency. Frequency is 2 pi by omega. Am I right, sir? And therefore this will be 2 pi upon under root of K squared minus B squared. Therefore, F will be equal to 2 pi by omega. Omega by 2 pi, sir. Sir, it is omega by 2 pi. T is 2 pi by omega. Therefore, omega by 2 pi. Therefore, under root of K squared minus B squared upon 2 pi. Because if you have doubt, 2 pi by omega is the time period, frequency is 1 upon T. Okay. Therefore, 1 by 2 pi under root of 1 by LC minus R squared by 4L squared. If R is equal to 0, then F becomes equal to 1 by 2 pi root LC. This is the condition for checking whether the circuit is oscillatory. This is how you will check whether the circuit is oscillatory or not. If oscillatory, you will find out what is the frequency using this expression. Sir, these are the expressions. Must remember expressions. Okay. This is a very lengthy derivation. We have one more topic to go here. The discharge of a capacitor through resistance and inductance. Time is up. I will stop here. God willing, continue in my next class. Until then, goodbye.